So what I'd like to talk about really quickly here are the quizzes from 2021. We had 5 quizzes. However, one of them was done using Wiley Plus, and it didn't work out the way we had expected. So I'm not going to go over that one. It ended up not quite being what we had in mind. So, and just as a reminder for those going forward, this was the year of coronavirus, and we were doing online teaching. So what are we looking for when we look at a quiz? So first quiz, quiz 2, we have a wagon, which is moving up a ramp, and you have a crate, which is on top of that ramp. So wagon B, crate A, theta is equal to 27 degrees, mass of A is 10 kilograms, mass of B is 20 kilograms, and you're given mu K and mu S of 0.15, 0.19. Acceleration of B is given as 1.2 meters per second squared, and velocity of B is given as 2.7 meters per second. And it's moving along that 27-degree ramp. X and Y is given to you in the upper middle of this, and you have G, which is given over here. Knowing that crate A slips on B and B moves up and to the left as shown, what is the acceleration of A in the XY coordinate system? Shown. Assuming A moves to the right, what is the friction force between A and B? So we have the XY coordinate system that's given. We have the crate A, which is the only crate that matters. So the only thing that matters in this particular problem is crate A. B isn't going to play any role in this really, so you'll see that in a minute. You have the force balance, which is going to be forces in the x direction. That's only going to be force of friction, which is negative, and mass times acceleration x. You have normal force and weight, which are acting up and down, respectively. And so n minus mg equals m times acceleration y, because you know the crate is moving up the ramp. We also know, because we're given that the friction, or the crate is slipping, that force of friction equals mu kn. Now, acceleration of the crate relative to B is only in the x direction, and so acceleration of A relative to B is acceleration A relative to B in the I direction. And we can write that as acceleration of B plus acceleration of A relative to B equals acceleration of A. You're given all of the information about acceleration B. So acceleration of A is equal to acceleration A relative to B minus AB cos theta, because I just bring this term over to this side, and I get all of the rest of the terms. So everything is there, everything I need to know, and I know the direction of things moving. This is moving down the ramp, or this is moving in the negative x direction. This one is moving up the ramp. So substituting in terms, I've got forces of x minus mu kn, mass times acceleration ab minus ab cos theta, just substituting in the expression I just figured from my kinematics, n minus mg equals mab sine theta. Putting all the terms together, solving, I end up with this, which is just acceleration of A in terms of the I and j components, and force of friction, which is minus 15.532 in the I direction newtons. Okay, so that was easy, no problem. But some people checked for slip. And when they checked for slip, they figured out that it couldn't slip. And so you ended up with a slightly different result. You still had to solve for the same thing, but you did get a different force of friction because this crate actually didn't slip. So this is a case where I didn't check for slip, and so I ended up in that problem. I have here a disk for quiz 3, and it has a radius of 3 meters, so a disk A, and disk B has a radius of 4.5 meters. Both disks roll on the ground without slipping. Bar DE, this bar right here, has a length of 60 meters and pinned to the disks as shown. Point D is at the top edge of disk B. Point D is located 0.8 meters from the edge of disk A. So just slightly off, but it is still in the vertical center line at that instant. Directly below the center of gravity of A at the instant shown, omega is equal to 0.75 rads per second for disk A. Find the velocity at point K on at the edge of disk A. Express your answers in the xy coordinate. Find the location of point K, express your answer in r theta coordinates, and omega dE for bar dE and omega B for d. So if we start first with the solution, we have velocity of A, which was given basically as omega A RA in the minus I direction. So you solve through for all the terms, you get minus 2.25 meters per second I. For velocity of K, it's equal to velocity of A plus velocity of K relative to A. Substitute all the terms and then go from A to K, and that distance is RA sine 30 in the J direction, RA cos 30 in the I direction. And if you do all of these things together, you end up with velocity of K, it's minus 2.25.75 rads per second, 3 meters, sine 30, J minus cos 30, I. So the total value is there. There you go. For the next step, you have velocity of or the position of K. And I've been asked a couple of times on Piazza, why did we ask this question? And often we ask questions like this, not because we have some super secret plan here, but we want to test the concept. And here we wanted to test radial position understanding and essentially coordinate transforms. So R is given as a distance from the origin, 8.5 meters and 5.6 meters squared, and theta is just 5.6 over 8.5, or 0.58 radians, so 33.838 degrees. Finally, you have the direction or the velocity of d, which is equal to velocity d plus velocity d relative d. Both velocity d and velocity are horizontal, and velocity d and relative d has both horizontal and vertical components. So if you do all the calculations, you'll find the velocity of d relative d equal to 0 and omega dE is equal to 0. Substitute in all the expressions, velocity of d, 2 times radius b, so 0.6 meters per second, divided by 2 times 4.5 meters, you get 0.067 rads per second, or 0.067 K rads per second. Alternatively, you could have done this as a vector solution, and if you do, you can put position of K in terms of rad A sine theta, rad A plus rad A cos theta, calculate all the terms, and you solve everything relative to A, and you end up with the same terms, minus 4.2I plus 1.13 J meters per second. Rad K, distance, same thing as before. And finally, for velocity of d, it's equal to velocity d relative to E, and you get minus 0.6 I meters per second, and omega dE is equal to 0. One advantage of this approach is that if you couldn't intuitively see the results in the previous solution, this one doesn't require you to have that intuition. It allows you to work on it without having to going through all the rest of it. Omega b is equal to 0.067 rads per second K, and that is done by inspection. Just so you are aware of this, and this is a question that came up multiple times on Piazza, why exactly the difference in terms of position? And here's sort of the position vector for RA sine theta, RA cos theta, and RA relative to everything else. So just a similar sort of diagram just to get the same results. What happened if it was revolutions per second? So same sort of approach, I just did this as a vector approach. You get different results. People made this mistake, and I just put this in as a solution. This is completely and utterly wrong because it was misinterpreted at the beginning. But revolutions per second are not the equivalent to rads per second. Quiz 4 was a rigid body kinetics problem. You had a uniform disk A that slips on the belt with a mu K of 0.4. Neglecting the weight of the link AB, which is 2 meters long, and using the coordinate system, which is a standard one, x, y, positive and counterclockwise positive. Draw a free body diagram of the disk, and this is something you should be doing just normally. Determine the forces exerted by the belt onto the disk, and determine the angular acceleration. So if you put all the terms in, over here you have all of the forces. So you have normal force and you have friction force, you have weight acting downward, you have force of the link AB, and often the problem was often this point right here where it was done in a way that didn't seem intuitive. You kind of have some difficulty seeing how this belt is sort of doing this. It's fine. Just get used to writing the friction down. So it allows you to write it as a positive value, so n minus FAB costate in the y direction, the x direction. And over here, friction force, you have the component of the belt force and the weight acting in the y direction. Substitute in all the terms, you calculate everything. And you also know that the force of friction times r is the only thing that's causing a moment about g. And here you'll end up with alpha is equal to r divided by ig, moment of inertia, times force of friction, or minus 20.4 rads per second squared. So you kind of expect a clockwise alpha here. Finally, it's a vibrations problem. This was quiz 5. The block can move up and down. Find the natural frequency of the vertical oscillations of the 50 kilogram block when it's set in motion. Each spring has a stiffness of 20 newtons per meter. Neglect the mass of the pulley. Use the coordinate system. So you have a mass here. You have two pulleys, same ones, with K equals 20 newton per meter. And you have a massless pulley over here. You have X, Y, and G over here. First thing you do, you calculate your force of friction, or force in the tension. Tension is acting downward, and it's on each spring. Now, often this was a problem. Why did you make it 2ky? Because this spring, as it goes around, is an inextensible cord, and it's attached, so it's a fixed length. So the only way you're going to get extra length is by just stretching the spring. And so the spring takes up all of the stretch, K times 2y. So tension is acting upward here. You have weight acting downward. So sum of forces in the y direction for the crate, mass of the crate minus 2t, mass of the crate y double dot. And you end up here with your omega n squared. And omega n is not going to be k over m. It's going to be 8k over m in this case. And that's the tricky bit, because you have two crates, two tensions, or two pulleys with tension 4ky. Total is going to be 8ky. And I also got rid of the static component here. The static component here. And so once you do this, you have omega n, which is going to be 8k mass of the crate, square rooted, or normal frequency, or the natural frequency, which is omega n divided by 2 pi. This one is in rads per second. This one is in hertz. Omega n is 1.79 rads per second, and frequency, natural frequency, natural circular frequency, and natural frequency is going to be 0.285 hertz. Different from previous year. Again, we chose to do a different way with quiz 1, and that really doesn't sort of do things as we do in the past. Now, big difference from previous years is that instead of having a single quiz and a midterm, we had 5 quizzes over the term, and so as a result, it was the same thing as quiz 1 and a midterm, but it was one event for about 45 minutes for each one. Generally, same approach as the past, however. Thank you very much, and we'll talk again.